By 2026, the consensus among technical leaders is clear. Tool calling is no longer a niche feature. It is supported by every major LLM provider, from OpenAI to Google and Anthropic. It's the mechanism that changes AI from a text generator into a functional extension of our software systems. We've spent years using chatbots as passive entities. They generate words to answer a prompt, but once the text is on screen, the interaction ends. An AI agent is built for autonomy. It uses those same language models as a reasoning core to execute multi-step tasks in the real world, interacting with APIs, databases, and file systems. This marks the move from generative AI to agentic AI. It's a transition from a system that produces words to one that takes actions. We are moving past the phase where AI is just a conversationalist. In the modern organization, it is becoming a digital subordinate. To understand how this works in a practical setting, look at a typical office workflow. Using a standard chatbot is like stopping by a colleague's desk to ask a specific question. You get the data you need, and then you go back to your desk to do the actual work. Using an agent is like handing that same colleague an entire project with a defined objective. Once they have that goal, the agent independently breaks the project into logical steps. It searches my data, it compares results, and modifies files, operating on its own until the project is complete. This changes your role from an operator who manually prompts every task into a director who manages the inputs and validates the results. An agent's architecture is built on 3 distinct pillars: brain, memory, and tools. The brain is the large language model. It provides the core reasoning logic that allows the system to understand a request and plan a response. Memory allows the system to track its progress. It stores the state of a multi-step project, so the agent doesn't lose context as it moves through a long-running task. Finally, tools are the agent's hands. These are the functions that let the model query a database, search the web, or send an email on your behalf. But for an agent to be useful, it needs a way to talk to the software we use every day. That's where the Model Context Protocol, or MCP, comes in. Think of MCP as a universal connector, like a USB-C cable for intelligence. It provides a standardized way for an AI's brain to plug directly into any external software application. When you combine a reasoning core with persistent memory and standardized tools, AI can finally reach outside the chat window to manipulate the digital environment. Imagine you tell an agent to compare the B2B pricing models of 2 competing vendors. The agent first formulates a plan. Instead of typing a response to you, it outputs a structured JSON command, a specific code format that tells the system's runtime layer to initiate a web search. The agent executes the search, extracts data from both sites, and feeds those results back into its own reasoning engine to see if the goal has been met. Finally, it delivers a synthesized report. You get the analysis without managing any intermediate steps between the prompt and delivery. In focused use cases, this loop has produced efficiency gains of 10x. It's why we're seeing software payback periods collapse from years to just 4 to 9 months. But moving from a single test to an enterprise-wide rollout creates a new kind of friction. Gartner warns that in one case, an e-commerce agent misread a competitor's clearance sale and slashed prices by 40% across 2,300 items, running for nearly an hour before anyone noticed. When an action is irreversible, like deleting a file or executing a payment, an unsupervised error is a financial risk. This is why production-scale agents use human-in-the-loop architecture. As shown in this data interface, a person remains over the loop to provide validation and direction. For high-risk tasks, the system hits an approval gate. The agent pauses its execution loop and waits for a human to review the proposed action. The task only moves forward once a person authorizes it. Adding these checkpoints reduces critical errors by nearly 80%. Agents aren't replacing entire jobs. They are consuming the repetitive, multi-step tasks that make up those jobs. The goal of 2026 isn't total autonomy, it's human-directed automation. Knowing that, which of your repetitive tasks are you ready to delegate first?